Hello everyone, welcome back to my channel. So in this video we would be studying about preemptive shortest job first algorithm, or we also call it as shortest remaining time first. So here we have been given four processes, their arrival time and burst time. So let's start with time t is equal to 0. So at 0 unit we have only one process with us, that is p0. So we allocate it to p0. Now at time unit 1, what we see is that we have a new process coming in that has 4 units of burst time and the remaining time. Now what we basically need to see here is the remaining time. So since P0 has already completed 1 unit of time at time t is equal to 1, so the remaining time is 7. Now among 7 and 4, the minimum would be 4, so we'll rather allocate it to P1 instead of P0. So that's why since we preempt P0, we call it as preemptive. Now after that what we see is that next at time t is equal to 2, we have 3 processes with us. So here what we have, that this 7 remains the same, and since we executed 1 unit of time of P1, so this becomes 3. Now we'll compare these 3. So we have 7, 3 and 9. So the minimum is still 3. So we'll allocate 1 more unit of time to P1 only. Now then at time 3, what we see is that P3 is having a burst time of 5 and remaining time for P1 is 2. Now we see 7, 2, 9 and 5. So here what happens is that still P1 is the least. So we allocate the time to P1 only. So we see that the whole time is given to P1. So it finally finishes at time 5 units. Now we know that all of the processes have already come in queue. So now it would be like the non-preemptive shortest job first algorithm only. Now when all the processes have already entered, then the execution is similar to non-preemptive shortest job first. So now we'll see the remaining times. So since this has been already completed, this P1 has been already completed, so we are not going to look at it. Now we have P0, P2 and P3. So we see that P3 has the minimum one, so we give it to P3. So that gets completed at 10 units because the burst time is 5. Then among P0 and P2 we have P0. So we allocate this to P0, which gets completed at 17 because 7 units of time was remaining. And then finally we give it to P2. So P2 finally gets completed at 26. So now let's compare the completion time of all of these processes. So first of all, what is the completion time for P0? So we saw that it got completed at time t is equal to 17. Then for P1 it gets completed at 5. Then P2 gets completed at 26. And P3 gets completed at 10. Now let's calculate the turnaround time. So turnaround time would be 17, 4, 24 and 7. Then the waiting time. So waiting time, as we know, it's turnaround time minus the burst time. So we'll have 9, 0, 15 and 2. Now what we can see here is that we have waiting time for the P1 0 because we got P1 completed immediately. Now let's calculate the average turnaround time and average waiting time. So first of all, the average turnaround time. So that would be the sum of this, which would be equal to 52 divided by the total number, that is 4. And the average waiting time would be equal to the sum of this divided by 4. So the sum of this would become 26. So 26 by 4. Now let's discuss a few important points of this algorithm. So first of all, what we know here is that it gets the minimum average waiting time among all the algorithms, among all the scheduling algorithms. Then the second important point for this is that it may cause high waiting and response time for CPU bound jobs. So since we know that CPU bound jobs utilize high amount of time on CPU, so that is why it has high waiting and response time, because we saw that the shortest job is given the priority in this algorithm. Then finally the last point is that it's quite impractical. Now why is this impractical? So we see here that for executing this algorithm we should already know the burst time for the jobs in advance, which means that we already know how much time will a particular process take, but that's not practically possible where we already know that yes, this process is going to take this amount of time. So that is why this is an impractical approach, but it also has a lot of benefits because of which we study this. And that's it for preemptive shortest job first algorithm. We'll meet in the next video with another scheduling algorithm.